What is conductometry? A. A technique to measure temperature changes. B. A technique to measure electrical conductivity. C. A technique to measure color changes. D. A technique to measure pressure changes. The correct answer is B. Conductometry is a technique used to measure the electrical conductivity of a solution, which is related to the concentration of ions in the solution. Which of the following is not a factor affecting the conductivity of a solution? A. Temperature. B. Pressure. C. Concentration of ions. D. Nature of solvent. The correct answer is B. Pressure is not a factor affecting the conductivity of a solution. Temperature, concentration of ions, and nature of solvent do affect conductivity. What is a conductivity cell in conductometry? A. A device used to measure the color changes in a solution. B. A device used to measure pressure changes in a solution. C. A device used to measure the electrical conductivity of a solution. D. A device used to measure temperature changes in a solution. The correct answer is C. A conductivity cell is a device specifically designed to measure the electrical conductivity of a solution. What is the principle behind conductometric titrations? A. Temperature changes in the solution. B. Color changes in the solution. C. Electrical conductivity changes in the solution. D. Pressure changes in the solution. The correct answer is C. Conductometric titrations are based on monitoring the changes in electrical conductivity of the solution during a titration. Which of the following is an application of conductometry in pharmaceutical analysis? A. Identification of organic compounds. B. Quantification of drug concentrations. C. Measuring O-phase absorption spectra. D. Monitoring gas production in reactions. The correct answer is B. Conductometry can be used in pharmaceutical analysis for quantifying drug concentrations in solutions. How does the concentration of ions in a solution affect its conductivity? A. Higher ion concentration leads to higher conductivity. B. Higher ion concentration leads to lower conductivity. C. Ion concentration has no effect on conductivity. D. Ion concentration only affects temperature changes. The correct answer is A. Higher ion concentration in a solution generally leads to higher conductivity due to increased charge carriers. What type of titration technique is conductometric titration? A. Colorimetric titration. B. pH titration. C. Redox titration. D. Conductometric titration. The correct answer is D. Conductometric titration is a type of titration based on measuring changes in electrical conductivity during the titration process. In a conductometric titration, the equivalence point is reached when A. There is no change in conductivity. B. The highest conductivity is observed. C. The lowest conductivity is observed. D. A color change is observed. The correct answer is C. The equivalence point in a conductometric titration is reached when the lowest conductivity is observed, indicating that the reaction is complete. Which of the following statements is true about conductivity cells in conductometry? A. They are used to measure pressure changes. B. They are only used with colorimetric techniques. C. They can vary in design and electrode material. D. They are not affected by temperature changes. The correct answer is C. Conductivity cells can vary in design and the material of the electrodes used, allowing for flexibility in measuring the electrical conductivity of solutions. What type of curve is typically obtained in a conductometric titration plot when plotting conductivity against volume of titrant added? A. Linear. B. Parabolic. C. Sigmoidal. D. Exponential. The correct answer is C. A sigmoidal curve is typically obtained in a conductometric titration plot due to the change in conductivity at the equivalence point. Which of the following factors can affect the conductivity of a solution in conductometry? A. Temperature. B. Pressure. C. Color of the solution. D. Odor of the solution. The correct answer is A. Temperature can affect the conductivity of a solution in conductometry as it can influence the mobility of ions. What is the purpose of using a conductivity cell in conductometry? A. To measure the color of a solution. B. To measure the pH of a solution. C. To measure the conductivity of a solution. D. To measure the density of a solution. The correct answer is C. A conductivity cell is used in conductometry to measure the conductivity of a solution by passing an electric current through it. In a conductometric titration, what does the endpoint represent? A. Starting point of the titration. B. Equivalence point of the titration. C. Midpoint of the titration. D. Endpoint of the titration. The correct answer is B. The endpoint in a conductometric titration represents the equivalence point where the moles of the reactants are stoichiometrically equivalent. Which of the following is true about the detection of endpoints in conductometric titrations? A. Endpoints are determined visually. B. Endpoints are determined by a sudden change in conductivity. C. Endpoints are determined by titration with an indicator. D. Endpoints are determined by measuring pH changes. The correct answer is B. Endpoints in conductometric titrations are typically detected by observing a sudden change in conductivity due to the completion of the reaction. What is the purpose of a reference electrode in a conductivity cell for conductometric measurements? A. To measure the temperature of the solution. B. To provide a stable potential for the cell. C. To measure the pH of the solution. D. To determine the color of the solution. The correct answer is B. A reference electrode in a conductivity cell is used to provide a stable potential for the cell, ensuring accurate conductivity measurements. How does the conductivity of a solution change with an increase in ion concentration? A. Conductivity decreases. B. Conductivity remains constant. C. Conductivity increases. D. Conductivity becomes zero. The correct answer is C. The conductivity of a solution increases with an increase in ion concentration due to the higher availability of charged particles for conducting electricity. Which of the following statements is true regarding the use of conductivity cells in conductometry? A. Conductivity cells are used to measure the resistance of a solution. B. Conductivity cells are used to measure the voltage of a solution. C. Conductivity cells are used to measure the conductivity of a solution. D. Conductivity cells are used to measure the pH of a solution. The correct answer is C. Conductivity cells are specifically designed to measure the conductivity of a solution by passing an electric current through it and measuring the resulting conductance. What happens to the conductivity of a solution during a conductometric titration as the titrant is added? A. The conductivity remains constant throughout the titration process. B. The conductivity decreases as the titrant is added. C. The conductivity increases as the titrant is added. D. The conductivity becomes zero at the equivalence point. The correct answer is C. As the titrant is added during a conductometric titration, the conductivity of the solution typically increases due to the formation of ions that contribute to conductivity. Which of the following is a critical factor that can influence the conductivity of a solution in conductometry? A. Temperature of the solution. B. Color of the solution. C. Odor of the solution. D. Turbidity of the solution. The correct answer is A. Temperature is a crucial factor that can significantly affect the conductivity of a solution in conductometry as it impacts the mobility of ions. In a conductometric titration, what does the endpoint signify? A. The start of the titration process. B. The change in color of the solution. C. The volume of titrant added. D. The completion of the reaction between the analyte and titrant. The correct answer is D. The endpoint of a conductometric titration represents the completion of the reaction between the analyte and titrant, indicating the equivalence point. Which material is commonly used for making the electrodes in a conductivity cell for conductometric measurements? A. Aluminum. B. Copper. C. Platinum. D. Gold. The correct answer is C. Platinum is a common material used for making the electrodes in a conductivity cell due to its inertness and stable conductivity properties. What is the primary function of a conductivity cell in conductometry? A. To measure the resistance of the solution. B. To measure the conductivity of the solution. C. To titrate the solution. D. To determine the pH of the solution. The correct answer is B. The primary function of a conductivity cell in conductometry is to measure the conductivity of the solution, helping to determine the concentration of ions present. Which of the following factors can affect the accuracy of conductometric titrations in pharmaceutical analysis? A. Temperature of the solution. B. Type of electrode material used. C. Size of the conductivity cell. D. Volume of the titrant added. The correct answer is A. Temperature of the solution can significantly affect the accuracy of conductometric titrations in pharmaceutical analysis, as conductivity is temperature dependent. What type of relationship exists between the concentration of ions in a solution and its conductivity? A. Linear. B. Inverse. C. Exponential. D. No relationship. The correct answer is A. There is a linear relationship between the concentration of ions in a solution and its conductivity. An increase in ion concentration leads to higher conductivity. Why is it important to calibrate conductivity cells in conductometric measurements? A. To ensure the pH of the solution is constant. B. To account for variability in electrode materials. C. To adjust for changes in room temperature. D. To validate the accuracy of conductivity measurements. The correct answer is D. Calibrating conductivity cells is essential to validate the accuracy of conductivity measurements and ensure reliable results in conductometric analysis. Which of the following is a primary factor influencing the conductivity of a solution in conductometry? A. Temperature. B. Color. C. Density. D. Viscosity. The correct answer is A. Temperature is a critical factor affecting the conductivity of a solution as it impacts the mobility of ions in the solution. What is the purpose of using a conductivity cell with fixed dimensions in conductometry? A. To ensure consistent results. B. To change the pH of the solution. C. To increase the viscosity of the solution. D. To add color to the solution. The correct answer is A. Using a conductivity cell with fixed dimensions helps ensure that the same path length and area are maintained for consistent and reproducible results during conductivity measurements. In which type of pharmaceutical analysis would conductometric titrations be particularly useful? A. Determination of acid-base reactions. B. Measurement of optical activity. C. Quantification of organic compounds. D. Detection of heavy metals. The correct answer is A. Conductometric titrations are particularly useful for determining acid-base reactions in pharmaceutical analysis due to the sensitivity of conductivity changes during titrations. Which of the following electrode materials is commonly used in the construction of conductivity cells for conductometric measurements? A. Plastic. B. Aluminum. C. Silver. D. Platinum. The correct answer is D. Platinum is a commonly used material for the electrodes in conductivity cells due to its inert nature and good conductivity. Why is careful calibration of conductivity cells necessary in conductometric measurements? A. To change the properties of the solution. B. To introduce errors in the analysis. C. To ensure accurate and reliable results. D. To decrease the conductivity of the solution. The correct answer is C. Calibration of conductivity cells is essential to ensure that accurate and reliable results are obtained during conductometric measurements by accounting for any variations or inaccuracies in the cell setup. What is the role of a reference electrode in a conductivity cell used for conductometric measurements? A. To introduce icons into the solution. B. To measure the conductivity of the solution. C. To provide a stable potential for comparison. D. To increase the temperature of the solution. The correct answer is C. The reference electrode in a conductivity cell provides a stable potential for comparison, helping to measure the conductivity of the solution accurately. What is the significance of the endpoint in a conductometric titration in pharmaceutical analysis? A. It marks the start of the titration process. B. It indicates the stoichiometric equivalence point. C. It identifies the initial concentration of the solution. D. It shows the color change of the solution. The correct answer is B. The endpoint in a conductometric titration signifies the stoichiometric equivalence point where the reaction between the titrant and analyte has reached the ideal molar ratio for neutralization, commonly indicated by a sharp change in conductivity. What is the function of a reference electrode in a conductivity cell for conductometric measurements? A. To measure the specific conductance of the solution. B. To maintain a constant potential during the measurement. C. To detect the endpoint of the titration. D. To determine the type of icons present in the solution. The correct answer is B. The reference electrode in a conductivity cell is used to maintain a constant potential during the measurement, ensuring accurate conductivity readings. What is a common material used for making the electrodes in a conductivity cell for conductometric measurements? A. Gold. B. Copper. C. Platinum. D. Silver. The correct answer is C. Platinum is a common material used for making the electrodes in a conductivity cell for conductometric measurements due to its inertness and conductivity. Which factor is not a critical influence on the conductivity of a solution in conductometry? A. Temperature. B. Concentration of icons. C. Volume of the solution. D. Type of solvent. The correct answer is C. The volume of the solution is not a critical factor influencing the conductivity of a solution in conductometry, as long as the concentration of icons is maintained. Why is it important to calibrate conductivity cells in conductometric measurements for accurate analysis? A. To determine the concentration of icons in the solution. B. To ensure the cells are cleaned properly. C. To account for variations in electrode materials. D. To establish a linear relationship between conductivity and concentration. The correct answer is D. Calibrating conductivity cells is crucial to establish a linear relationship between conductivity and concentration, ensuring accurate analysis in conductometric measurements.